Thank you, Don. All right, we're recording now. First slide. Don't worry, you didn't miss anything if you're on YouTube. So, well, you missed the agenda, but you'll you'll be surprised. So we're now officially over 7,000 total members. We had a plus 258 since the last time we met. Our PyPy downloads continues to really move. We're up another million on the last month, 1.2, almost 0.3, which is incredible. So very exciting to continue to see that growth, which means more great things for the open source, great expectations. So probably the most important slide, just want to give some thanks and kudos to some recent contributors. It's also where you get to laugh at me pronounce names. Mo Bukowski, I'm not going to try this one, but thank you very much. Hopefully you can see my mouse right here. And then Andy Jessen. So shout out to some of our top Slack supporters. Big shout out to Veronica Moy, who's been super active in the chat, and then some new people who are helping out in Slack, like Daniel and Mahmood. So really, thanks so much. Oh, I have John on here twice. Congratulations to John. John 2 times. Good job. All right, cool. Just one more quick thing before I hand it over to Don. I just wanted to point out that all the expectations from the hackathon are now in the gallery. We went from 125 to 265. So please go check out the gallery. There's tons of awesome expectations in there, and contribute some of your own. So yeah, that's it for me. I'm going to hand over to Don.
Hey, so talking about the Great Expectations roadmap. The nice thing about roadmaps is that they don't change that much. So some of this will be a repeat of before, and that's kind of a good thing. So the way that I frame our roadmap and what we're hoping to deliver is around this statement, looking for this to become true, that it's Great Expectations is powerful and expressive. After years of development and widespread adoption, the core APIs are robust, stable, and thoroughly tested, and it's easy to get started. So kind of looking over the year and what we've done. On the next slide, Kyle. We've made investments in docs and developing guidance for new expectations that were featured at the hackathon. We shipped the V15 release to introduce code standards and standards way of deprecating code, as well as to mark the retirement of Python 3.6 support. That's what warranted the minor version bump. And with the V15 release, we also added, continue to expand the capabilities of profilers and data assistants. And if you've monitored the point releases through V15, you'll see the volume data assistant drop and a lot of work that we're doing around the onboarding assistant, which will be the next big one that's coming. We've got a lot of the data work done for that, and have been doing some really neat work around the plots and continuing to invest in the charting capabilities of data assistants as well. So, which is awesome demoable work that we've shown on the last couple meetups. Continuing on to what we plan to do, continue to make it easier to get started with the data assistants that I mentioned and new data connectors, and then adding support for batch metrics to be able to do multi-batch expectations and for reporting purposes. The metrics themselves become a really interesting data stream, especially when you know that what we've recorded as metrics are a product of what you've asked us to record as metrics by virtue of expressing your expectations for data. So I think that relationship is really powerful, and us making that available as a source of raw information then curated within the framework is going to be really neat. Additional work we're planning to do, yeah, you can go to the next slide, Kyle, is better test suites for integration partners. And we've really got some muscle in our DevRel team now, with Ken and Ruben in particular, supporting integration partners coming up to speed with the platform and trying to do so in a way that sets the standard that allows us to very quickly onboard future partners. So excited for that. We're going to be publishing some coding standards. We've got type hints, doc strings, all kinds of things that different references between our docs and our code that we're continuing to make better. So we've put in constraints within our CI process that accepts PRs into the develop branch, saying that, hey, if you're adding code, it needs to enrich our type hints, it needs to enrich our doc strings, it needs to ensure that our documentation code references are maintained and whatnot. And so that there's never any backsliding, and with every commit, the threshold of tolerable code that is missing type hints or missing doc strings, that threshold is continually dropping with the goal of targeting 0 there. And then Rachel has been prototyping and iterating on public API documentation. Right now, a lot of our docs are in the legacy docs part for API docs on the site. And this is really neat work. It's going to both clearly define what we consider public API, which helps inform what we consider a breaking change. So most importantly for the team, that's the areas of the code where we need to be careful in making changes to ensure that we don't break things from one version to the next. But then also just the docs are great, and they link into all of the other great docs. So what that means is if you're looking at data context as a public API documentation, it'll link to the longer usage style documentation that's already written that supports interacting with data context, as an example. And a V16 release is shipping summer-ish, like maybe more in line with the summer that you'd experience in a southern state than a more northern one. That'll include the metric store and the new data connector work. And that's it. If there's any questions, I'll answer them in the Slack chat.
Sorry about that, I was muted. Great, thanks so much, Don. Yeah, like Don said, please feel free to ask questions while we're in the presentation, and we'll make sure to answer any ones that pop up. So next, we have Rob.
Hey everyone. So I thought I'd do something fun today and present a hackathon project I worked on about a year ago at one of our company offsites. It won us the hackathon. So about a year ago, I thought it would be cool to figure out how to get Great Expectations to reach out into the physical world. So as a lot of you know, you can set up Great Expectations to send out Slack notifications or emails, and I thought it would be cool if we can connect Great Expectations to the Internet of Things. Looked into it, and it turns out it was pretty straightforward. We chose to integrate with If This Then That. If you're not familiar, it's a really great service that brings together a lot of Internet of Things services. So you can get like a notification that fires off different actions. And then for myself, I integrated with my Home Assistant home automation system. These are some screenshots from our demo. It's an old colleague, Taylor, and you can see that he is getting soaked from his data validation failing. So yeah, I'll go ahead and just walk through the different ingredients. There's a link to the repo with the plugin that I created down here, and also in the Great Expectations Slack if you have any questions. So first ingredient is If This Then That. So I created an applet. Very simple. We have an if statement. If we receive a web request with a JSON payload, then we're going to make another request and then blink my lights. And so I've just named this event, and then this will generate a webhook that we can then use in Great Expectations. After that, we can go over to this repo with this plugin. Grab the plugin. There are more instructions here if you want to get into it. And then after that, we just bring this this module into our Great Expectations project, and then put it into our plugins directory. GE is really easy to extend. We've implemented this custom notification action that basically just fires off a webhook with a payload on validation. And then after that, we set up an expectation suite and a checkpoint. So I have an expectation suite around room temperatures here. Expect them to be between -100 and 200. And then we have my checkpoint config, and I've added this very simple if this then that configuration. So once that's done, we're good to go. So going to pull up my terminal, and then we'll set up here. Let's see. Cool. Do you guys see my other Zoom with the mug and Bell?
No, we see the command prompt and PyCharm, I think.
Okay, let's see. It's another. I wonder if you guys. I'm gonna stop.
Oh, spotlight for everyone. Oh, I think I did it.
Can you guys see?
Right,
do you guys see the other window now?
Yeah, we see your other one.
Okay, cool. Great. So now I'm in my terminal, and then what I'm going to do is I'm going to trigger this checkpoint with good data. So all of my room temperatures are reasonable. Going to run this checkpoint. Okay, everything's great. We can keep running it. Everything's fine. Going about my day with no worries. Next, what I'll do is I'm going to go into this data set, and I'll just change one of the temperatures to something way out of range, like 2900, 4100. Okay. I'm going to save that, and then now I'm going to run this checkpoint. And we've triggered the webhook. Oh, and I forgot to show you guys what Home Assistant looks like. So I set up another webhook in my home automation system that takes requests, and if a webhook is received from if this and that with this particular payload, so expectation suite name, room temperature, with success equals false, then we trigger all of these actions, like flashing my lights, turning on my doorbell, and the little siren guy. Yeah, that's it.
Nice. Yeah, I was thinking we need to come up with an IoT swag idea. Like now I'm remembering that's the idea that I had after seeing this. If anyone has any good IoT swag ideas, definitely put it in the chat, because I'm open to it. I'm gonna make a swag store one of these days. So maybe I'll pick your idea. Cool. Well, Rob, thanks so much. If anyone could make sure they just check in on Prem's question in the chat and answer that'd be awesome. Otherwise, we'll give the mic to Taylor and Jeremy.
Awesome. Thank you for that introduction earlier as well. Let me just get my screen share going. are you all able to see my screen?
Yes.
Cool. Yeah, so I'm Jeremy Goodsa. I'm here with Taylor Turner. We're part of an applied research team at Capital One. And so we've been fortunate enough to be able to open source our work called the Data Profiler. And then a shameless plug, Capital One has a commitment to the open source community where we're trying to open source first. So we've been focused on that for a number of years and are continuing to do that. And the Data Profiler is one of those products. And so this is my team. One of the developers isn't on here. His name's Tyler Farnan, but just got to update the deck for that when he adds his slides. By the way, so what's data profiling? I'm sure you guys are all familiar at this point. It's just the ability to be able to point at a data set and get information from it, whether it's in a database or it's just a file on your local computer or whatever, or maybe it's a stream of data coming in, whatever that might be, just trying to understand what that data means and so being able to profile that. And so why do we need it? Number of reasons we need data profiling, and definitely a number of reasons why profiling fits in with great expectations, of course. As a modeler, I want to understand my data to be able to develop models. And that's kind of like what our applied research team is focused on, the machine learning AI aspect of things. So developing models, building the architecture, but also in pipelines, you need validation, great expectations. I need to know to make sure my data is what it's supposed to be, those data quality checks. So a profile is really critical to understanding that because you may not know what that data is as it's coming in. So being able to do those checks is obviously extremely important. But it's more than that, right? It's not just making sure the data is fitting the expectations. As me, a model developer, I will also want to make sure my data is not, changing so drastically that my model is no longer going to predict correctly. And so being able to detect when anomalies come in as a modeler and being able to detect when it drifts to like send off a signal, like maybe I want my, get shot by a super soaker. Maybe I want my, alarm doorbell to go off when my model is no longer doing things as expected, or I want to check to make sure the data isn't affecting my model incorrectly. So things like great expectations make an important component to being able to identify those things. And then some other interesting facets for profiles is if you have a data set and you understand what that data set looks like, you can create synthetic data, which we're seeing all over the place these days, whether it's image generation or there's tabular data set generation as well. Because for instance, a lot of data sets are confidential, but there's good reason to be able to share and make benchmark data sets that exist in the world. And so you want to be able to utilize, these profiles to create synthetic data off of them to be able to share them with other people. Again, driving towards, open source, being able to share data, whether, it's, being able to share data, starting with something confidential, being able to profile it, reduce it down, but still be able to share the essence of that data is really important. Giving people access to data they wouldn't otherwise have access to is really important. And then one of like our focus is, at least on my group, is being able to label data. And that's one of the components we'll talk about that we integrated into Great Expectations, is this idea that it's sometimes you don't know what's in a data set, right? But you want to make sure that data is not getting into places it shouldn't be. So that means, being able to identify or profile that data set, and we're using a machine learning model to do that and label it. It's like named entity recognition is essentially what it is, identifying if a column of a data set represents, someone's name or their social security number, or it could be benign, like maybe you just want to identify it, simple things like, is this just an integer, or is this, someone's bank account number, whatever the case that might be. Being able to label and then use, those expectations to ensure that either it fits within my expectations, we're not getting something outside of what we don't expect, or to identify when something, aberrant occurs, like I only expect, non-sensitive data to be in this data set, and now I can trigger something to say whether that may not be the case. And so why do we build the data profile to begin with? Because at the current, like when we started this, we wanted something that was really easy. And so a lot of our ideas around building this was trying to make things like just point at a data set, get your information, and do whatever you want with it. Whether that's for, like I said, pipeline validation, like integrating into Great Expectations, whether that's, being able to do security, so that data labeling component, or just, like I said, modeling, understanding your data is critical point. And we just wanted to make that super easy. And so our focus, at least for the library, was to do that. I think I skipped a slide. Yeah. One easy command to load it, one easy command to calculate it, and one easy command to then get your information from it. And then ideal is to do all the data over a single pass. And ideally O-event, not all the statistics can do that, of course, but that was our ideal pathway. And so like the library itself is really straightforward, just import and then point at the data class. And this is like a critical component that we focused on, was that we didn't want people to have to know what their data set was at all, which meant you could point any file at a data set using the data class and read that. And so whether it's CSV, Avro, Parquet, or JSON, or you could throw in a data frame if you want, it does that automatic detection and loading for you. And then that's easy enough to just throw into the profiler and then get your report out however you might want that to be. And of course, we added on top of that. So like updating and merging profiles. So like you can batch process your profiles and sum them all together into a single comprehensive profile. If it's online data that's streaming in through your pipeline, you could track that over time, or add that to a profile, because profiles should be dynamic. Data changes, data drifts. And that could be a good thing, actually, not necessarily a negative thing. But your profile should update as they go, and you shouldn't have to profile your entire data set all over again. You should be able to continuously update those profiles and continuously get those statistics. So that way you can change as your data changes. Of course, saving and loading is an important aspect, and then understanding the differences between profiles, another mechanism in which expectations can fall into play. And so obviously, we saw Great Expectation as a great opportunity and wanted to work with them on being able to utilize these profiles or these labeling or these different ideas to ensure that we're meeting, these data quality checks that we need in all these different aspects. And so I'm going to pass it off to Taylor.
Cool. Thanks, Jeremy. So we'll get to the next slide, and Jeremy kind of hit on this already. So really quickly, what we're going to talk about in the next half of the talk is some functionalities of the data profiler that kind of come to fruition in the expectations that we have contributed and plan to contribute down the road, which we'll get to that at the end. But this is as Jeremy said, this is a core feature of the data profiler, and like why it's really easy to integrate with Great Expectations. Obviously, the team is great to work with. But the data readers, as Jeremy said, you can point to pretty much any data source. You don't have to open the data. You don't have to understand the data. If you point to a URL, if you point to a file path, it will just read the data in. You can specify some header options, delimiter, etc. And then it just streamlines directly into the profiler, which makes development and iteration a lot faster. So that's the data reader. If we go to the next slide, this is kind of just a visual to kind of put the point home in terms of, if you look at, if you go to the next slide, maybe. Sweet, yeah. This is the whole idea. You can have multiple data sources, and they can all be different. You could have JSON, HTML, you could have like your traditional, structured data set. And the data profiler can read it all in and combine all that data and know what to do with it, and then give you outputs to then set expectations around and limits and thresholds around. So that's the loading functionality, which then leads us into the two other functionalities that are core to the data profiler, and that is profiling the actual data. So if you go to the next slide, or 2 slides, there you go. Profiling is broken down into 2 main profiling functionalities, and that is structured and unstructured, that are currently available in the package. So structured profiling is, you know, your traditional rows, columns, etc. And it will do column level statistics and global statistics about the entire data set. So if we think about like setting expectations on a pipeline, we could say, well, I want this column, or I expect this column's, you know, skew or kurtosis to be around this range. Or I could say my entire data set should have features that are similar to this, or within this range, or above this threshold. So there's a lot of kind of iterations you can do around that in terms of validation. Unstructured profiling is your, you know, traditional unstructured data, JSON, data labeling, vocab, words, etc. And you can actually add profiles together. Something that Jeremy talked about in the code snippet slide is you could create profile 1, and then you could create profile 2 and actually add them together, and it will work the back end such that you end up with one profile to, like, in aggregate see everything. So that's profiling. That's a big fundamental part of the expectations that we have built and plan to contribute more to, around taking the profiler and setting expectations and thresholds around the values that are returned. If you go to the next slide, this is just a simple, like, kind of visualization around, we have the data, we push it into the profiler, and that outputs, you know, 2 classes, either structured or unstructured. And you can specify that within the dp.profiler parameters. And the next slide is a simple kind of just GIF of the structured profiler. So you can see the global stats on the left, where you can gain insights about just the entire data set as a whole. And you see the key values, so you can see column count, all the, you know, data metadata. On the right, you can actually see the column level statistics. So you see standard deviation. You can look at quantiles, null values, mean, median, mode, max, etc. And that's for your structured data. And then if you go to the next slide, I think that covers unstructured. Yeah, it does. And that's kind of looking at your character level stuff, your word analysis, vocabulary statistics, etc. And we ultimately would love to actually contribute some stuff to Great Expectations around expectations for unstructured data. So if you have like NLP type problems, you could build expectations around that. So that's kind of profiling. There are some configuration options that you can add in to toggle things. So you can actually go on to particular metrics on a column level and enable or disable it. You can format the output, you know, print pretty and all that stuff. So it can save you a little bit of time where needed. And then labeling is the other core feature of it. You can actually go to the next slide, the structured data prediction. This is going to cover kind of the flow. Pretty simple, only a couple lines of code where you read the data in and then you're doing labeling. So it's on structured data in this example. And then you take the labeler, you do .predict on your data, and that's going to actually just output certain labels on the text. So it's going to look through there. There's actually a NLP model that will go through and identify things on a certain confidence value. And so I'm kind of jumping the gun, but this is actually a core part of the expectations that are currently in Great Expectations. We want to set thresholds around the confidence of the labeler's prediction. So if a phone number is only like 20% confident, we want to raise a flag. We would rather have, you know, phone numbers be 85+%. You can set a threshold in the expectation around the labeler's prediction. So that's the example there. And that's unstructured. The next slide kind of talks about the unstructured side of it. where we're actually just doing, your traditional NLP modeling, where it's labeling or identifying parts of the phrase or the sentence. I actually should say it's actually character level within this analysis, but it'll do email. You can see it's picking up the email and then doing your begin character number and character number. And again, the code to actually implement this is fairly simple. And you could use this within Great Expectations to say, hey, I want the threshold of the confidence to be a certain value. So that is profiling and labeling. These are actually some built-in examples of the labeler's predictions. So this is what it's trained on to find. So SSN, Jeremy talked about like sensitive data thresholds and expectations. Like if we expect no sensitive data in there, we could say, hey, we want to raise an expectation or we expect that no sensitive data could be in there. So like credit card numbers, SSN, and this is a great example of what Jeremy talked about with log data. So we could analyze that and say, hey, if we find credit card, we want the expectation not to pass because something's off. So there's a lot of things, and you can actually train your own labeler. So you could start with the current labeler and like build off of that and train additional epochs on that, or you could just start from scratch and build your own. You can do validation split parameters, you can do number of epochs, you can extend labels, you can group them, you can replace them, whatever. And then you can save and load the labeler with a command. So if you want to save a labeler and then reload it later down the road or in a different environment, you could have your artifact and do that. So
and I just want to add in here, Taylor, real quick, which is a critical component, because if you think about it, especially for the integration with Great Expectations, if by chance, the labels we have already provided aren't the labels that you are so desiring, that means you can customize your labeler for the expectations you desire.
So this is going to cover the actual expectations we've contributed, and then I'm going to talk a little bit about expectations that we want to contribute and like stuff on the roadmap. So we wanted to specifically build 2 expectations for an initial proof of concept around the threshold of the model's prediction confidence. So the first one was around, I just want to know in that column, in a particular column, I want the probability of the models or the threshold of the model's prediction to be a certain value above 0 or below 1, or you can see the float, greater than or equal to 0, less than or equal to 1. So that was the first kind of proof of concept, and we wanted to say, hey, if you have a column, we want that prediction of the labeler to be a certain value. The second one was around specific data labels. So if I give it a column and I know the column is like a phone number, I want the phone number's predictions to be a certain threshold. But if it finds something else, that's fine, but I want the phone number prediction specifically to be a certain threshold or confidence level. So the next 2 slides are kind of a quick GIF of actually showing you those implemented in a notebook. If you go to the next slide, we can actually see where there's an example data frame. You have phone number on the left. The first value is not a phone number. And then you run your expectation and it finds, hey, this is not an expectation. And I'm actually setting the threshold to 100%. So the other 2 values, that means those 2 values, the prediction was actually, this is a phone number at 100% confidence. So that's an example of the first one. The second one is covering where you actually say for a particular data value. If you go to the next slide, that's actually covering, so US state on that column, it's going to find that one of them is not a US state at 100%. So you can see in the partial unexpected list, you have you have that identified. And so the expectation does not pass because it's picking up on that threshold not being correct. So that is the two, those are the two expectations we have currently. Jeremy, before we go into roadmap or other things, do you have anything to add there?
No, I think good.
Okay, sweet. So the other things on the roadmap is more labeler validation expansion. So we want to add some more expectations around like the labeler itself and different values, predictions, and whatnot. We really would love to start dabbling in actually using the profile report, so the structured or unstructured profile values for validation. So we could say on a global level, we have an expectation that, you know, our column len is n value. I think there's a lot of development we could do around that for sure. And then there's always stuff. So we have this on our roadmap and definitely looking forward to contributing more. And it's been great so far. So that is all we have. I think we're going to questions, but I'll pass it back to Kyle, I think.
That was awesome. Thank you so much. Yeah, so I'm really curious about, it's really cool to see this open source project being born like inside of such like a big organization. Are there lots of open source projects coming out of Capital One?
Yeah, so we do have our own, obviously, Capital One repository where the data profiler is, and there's several other projects that exist there as well. Like I said, the synthetic data generation, we started integrating with the synthetic data library that's in the open source repository of Capital One. Or organization, I should say, their GitHub organization. So yeah, we are pushing towards open sourcing many of the products that we have or integrating into the projects that we have in our open source organization. And in fact, like so there's a slide that I'm not sure if it's on here, but we've open sourced quite a few things. I think back in like 2014 or 15, there's a couple projects that we open sourced that are now used by hundreds of organizations. I think we donated that to a specific organization for maintainability, but there are a few projects that are used that we have open source that are well used by hundreds of other companies. So it is a focus of ours, and it's just, I don't know, for us, it's super exciting that we can also be part of that.
Yeah, that's awesome. I'm definitely being a little selfish, not talking exactly the data profiler, but I was just really curious about that. And is it so it's open for contribution just by anyone?
Correct. Yeah. So if you see bugs or if you see features that you want to have implemented or added, by all means, throw up issues or add to it yourself. We are more than happy to have any contributions from anyone that wants to play a part in that. So
that's awesome.
We want to build with the community and for the community.
Yeah, that's excellent. Hopefully we'll get some more contributors on there that are coming in through Great Expectations, because there's tons of value with this package, especially as you all add more expectations. I'm sure others will get some good ideas to add in here too. I think I even see some people in the chat getting some ideas as we talk. So I'm going to stop hogging questions if anyone else has any questions for Jeremy and Taylor.
Right. I did see a few questions that I can bring up. There was a question about connecting straight to a NoSQL database. I think, if I recall, that was up earlier. And so I kind of talked about what the readers can do already. But again, like I said, if there are aspects that you want to add yourself, like we can't directly connect to databases in the current state, but if that's something you're knowledgeable in and it's not already on or like if it's not already being contributed or in the process, please feel welcome to add that yourself to library. We would be totally happy to have those contributions added. And then I saw another question about, in terms of like a use case for a non-technical colleague. I love this. Throwing in data that you know, doesn't might end up fooling the data profiler. So that's like, for us, it's really depending on how the data is read in, what might occur. Obviously, for our readers themselves, we trying to hit as high a percentage of use cases as possible. And so we did do some robust testing on interesting forms of data and commas. Let's see if I can find that. This being one of them, acts as delimiters with interesting spaces and things like that, and quotes and commas and things like that. And it was able to automatically do this sort of detection and automatically parse that, provided it's still delimited. And similar for JSON, while it is semi-structured, we do flatten that, and so it is able to handle JSON as well for structured analysis. So whether you want to read it as unstructured or structured is up to you. See here, there's another question. And by the way, cut me off if we're ever out of time.
No, you're good. Yeah, keep going.
In one of your slides, you mentioned about structured data predictions and unstructured data predictions. So great expectations using ML models to do the predictions. I'm trying to understand that exactly. Yeah, so right now the system is doing structured analysis, but it's not to say we couldn't have a model that's looking at unstructured text, and the validation being no data of a specific type exists in this unstructured text as an expectation. That's totally a feasible thing that could, you know, we could add to that gallery. And again, like, that doesn't just have to be us adding to that gallery. Like, if you guys see that expectation is valuable, like, bring that to the table too. We're happy to help and collaborate on that. Hopefully that answers the correct question as well. Is the current behavior to treat YAML files as semi-structured? Have not played around with YAML files, so I'm guessing it would be automatically be evaluated as unstructured currently, but that's another use case for a reader that could get added. I would love that. That sounds really good. And then what is the confidence really showing? This is a very good ML question. So ML models are interesting because, especially for the one we chose, so it's I'm going to get in a little detail here. It's a convolutional neural network at the character level, and essentially when it makes a prediction, it's predicting each character of what entity it suggests, and it looks around, you know, using its filters essentially, but that guess is independent. But when it's choosing the labels, like, it already has a pre-built set of labels, 25 of them, and the confidence is not to say this is the trick that you have to understand. It's the confidence that it's not any of the it's that label with respect to all of the other labels it could choose from. So if it's something the model has never seen, or it's not chosen to predict, you know, or one of the labels that it's like learn quote from, its confidence in that sense kind of becomes a little meaningless. Like, we do have an unknown label, so it's theoretically supposed to fall into that, but that could definitely confuse the model potentially. ML models are tricky like that, right? So confidence isn't that it is this label, it's confidence that it's this label with respect to the other ones it can predict within. So are there any other questions?
There's another question in the
Okay.
chat about data docs.
Data docs can show the data visualization after running or profiler. I don't know. Does anyone else here know about that? Data docs can show the data visualization after running our profiler. That might be one we might want to kick into our Slack channel. Yeah, I think we'll do that.
Trying to skip back up.
Taylor, Jeremy, I'm curious if you guys have any ideas for how you can apply an IoT device if you had endless resources for something like this.
And okay, so if we're using the data profiler And, here's an interesting idea. Let's say I was tracking the process of, making a recipe or cooking a recipe. Maybe I'm tracking the heat on that food specifically. And, one time I made it really well and I've tracked that data. I could create a profile on that data set. And then the next time I go to cook it, maybe I'm using that as combined with great expectations to ensure that I'm staying with the bounds of, how I cooked it before.
That's a good one. I like that. Yeah. That's nice.
We actually just planted a garden, and I was thinking about putting you could put a monitor in the ground to measure water saturation and notify you when you have reached a point where the plants are going to get too stressed and then you need to rewater ASAP. That was my first thought. I'm such a nerd, but it's good.
I love
like
it.
that.
That's pretty much what's funny. Taylor, who worked with us, who was part of Rob's original demo, those were IoT sprinklers that he would run off of his computer.
Perfect. I'm all about it. That's awesome.
Taylor, when are you gonna get that done? I'm excited.
Yeah, exactly.
Very cool. All right. Well, thank you both so much for the for open sourcing this and for partnering with Great Expectations and sharing those awesome expectations. I'm really excited to watch that package grow and see it in use in the community. And yeah, and everyone make sure, if you have suggestions for the Capital One data profiler, please, jump into their GitHub and make those contributions. Cool. I'm going to hand it off just for a moment. Ben, I'm putting you on the spot here. I'll do a little share on just on a single slide to talk about the quick mention of the cloud product. Let's see here. Let me just make it there. There we are.
Yeah, I am on the spot. No worries. Working with the go-to-market team on our cloud product. And if you want to learn more about that, definitely DM me or Alina, who's not here today. But we're excited to take a product to market that kind of helps more with some of the collaboration features that you might want in an enterprise setting.
Thanks, Ben. And you could also go greatexpectations.io/cloud is a place that you can sign up also for one of these to make it easy. So yeah, if you're interested, go check it out. Anyways, thanks everybody for coming. Thanks to all the presenters, and we'll see you next month, or I'll see you in Slack. Bye all.
Thanks, Phil.